This time we're going to discuss the third data structure, queue. Queue is an ordered collection of items or elements from which existing items may be deleted at one end, called the front end of the queue, and into which new items or elements may be inserted at the other end, which is called the rear end of the queue. And now a queue is just like the stack. It's like a vector array with two ends, like this one here, the vertical structure or the horizontal structure. Now recall that stack has two ends, but only one end is open, and that end which is open is called the top end of the stack, while the bottom end is closed. And therefore, for stack, you only perform at one end the two operations: insert, which is called push for stack, and the delete operation is called pop. So we call this open end the top end. Okay, that is the only open end, while the bottom is closed. So that is for stack. Now for queue, take note that there are two open ends, the front end and the rear end. So if this structure now is a queue, say for example, this is a queue denoted as Q. Okay, so the two ends are open. Say this is the rear end, and this one here is the front end. Or you could also represent a queue horizontally. Say this is the rear end, and this end here is the front end. So this part here is the rear end, this part here is the front end. Or if you represent it vertically, this one is the front end and this is the rear end. So say for example, we represent it vertically like this one. The insertion operation for Q is called NQ. That is the insert operation for Q. NQ, and take note, just like push for stack, there is one parameter which is the new element or new item to be inserted. While for Dequeue, which is the delete operation for queues, it has no parameter since we're going to delete only from the front end. We cannot delete elsewhere in the structure. So again, recall the definition that you delete from the front end. Okay, so delete from the front end and insert to the rear end. Okay, so delete from the front, insert to the rear end. And the operation insertion for Q is called, again, NQ, and for deletion or delete, it's called DQ. So say for example, we're going to NQ this element A, and then NQ element B. So this is the first to do, second to do, the third is say NQ letter C, and then the fourth operation is to DQ, and you could assign that front end which you delete from the queue to a local variable X in case you want to process it or need it at some point in your program. And the next, say we NQ D. Say these are the 5 operations to be performed. So NQA, we are going to insert at the rear end. So insert at the rear end A, and so it goes here. And the next, insert or NQ B. So this time we're going to insert or NQ B. And so B goes here. Next, we're going to NQ element C. And so we have C here. So the front now is A, the next is B, and the next is C. C is the rear element. The front element is A, and the rear element is C. Notice that every time we do NQ or insert a new element into the queue, we increment the rear. So initially, the front and the rear end are both 0. So this indicates that the queue is empty when the front and rear are both 0. So when you insert A for the first time, this time the queue has only one element, A. From being empty, it has now one element, A. What happens? You increment rear. So what happens here is that the front is still 0 and the rear is now equal to 1. So as an array representation, for example, of a queue, this element here is index 0, right? And this element here is index 1. This element is index 2, 3, and so on. So this is index 0, index 1, index 2, index 3, right? And then when we insert B, rear is again incremented because that's NQ. So when we have now A and B elements, rear becomes 2. When the queue has two elements now, A and B, front is 0, rear is equal to 2. And then when we NQ or insert C, the rear again is incremented, and so rear becomes 3. So front is still 0 and rear is 3. And this time the queue has 3 elements, A, B, C. C is the rear element, front element is A. So if you're going to implement a method in the class queue, a method that returns the size of the queue or the number of elements, it would be what? What is the implementation? It is simply to return rear minus front, right? So say for example, when there is still one element A, there is no B and C yet. Say if there's only one element A, the values of the front and the rear are front is 0, rear is equal to 1, right? So when you are going to inquire for the size of the queue, it would return 1 minus 0, which is 1, meaning there is only one element in the queue. When you insert B, now we have two elements already, A and B. The rear is equal to 2. From 1, it becomes 2. So front is 0, rear is equal to 2. That is when the queue has two elements, A and B. So when you are going to call size, it would give you 2 minus 0, it gives you 2, meaning there are two elements in the queue. So the formula for size or getting the number of elements in the queue is simply rear minus the front. When we insert or NQ element C, the third element, so C is now here, the value of rear is 3, right? So at this time, when there are 3 elements inside the queue, A being the front, next is B, and the third is C or the rear element, the value of front is still 0 and rear is 3. So when you get or call size to return the number of elements of the queue, it would give you rear is 3 minus the front is 0. It gives you 3, meaning 3 elements are inside the queue. When we dequeue, we perform the fourth operation, and that is to dequeue or delete the front end. So again, dequeue is to remove the item at the front of the queue. So when you perform dequeue, every time you perform dequeue, you are going to increment the front. What is the effect in this queue? Okay, at index 0, we have A. At index 1, we have B. At index 2, we have C. So when we dequeue, you increment the front. So front now, from 0, and rear is 3, from 0, it now becomes 1. That's the value of front, and it is pointing to B. Front is equal to 1, which points to B, having that index 1. And so that is considered as deleted or removed from the queue. So at this point, after we dequeue, if you're going to call size, it would return to us the value of rear is 3 minus the value of front is 1. So 3 minus 1, that gives us what value? 2, right? Which means that this time, after we dequeue, perform fourth operation, there are now 2 elements left in the queue, which are, what are these 2 elements? It is, the front is now B, so this is now the first element, and the next is C. Okay, so there are now only 2, B and C. So A is considered deleted. And then, when we perform the fifth operation, and that is to NQD, letter D, or insert letter D. So when you NQ, you increment the rear end. So this is now equal to, from 3, it now becomes 4. And we have in here letter D. Okay, so the rear end now is letter D. And what is the index of D? It is 3. Okay, so at this point, after we insert or NQ letter D, if we're going to call size, it would return to us rear is 4 minus the front is 1. It gives us 3, meaning there are 3 elements in the queue, and these 3 elements are starting from the front. Front is pointing here. This is the first, letter C is the second, and letter D is the third element. Now, the same is true if we're going to represent our queue as a horizontal structure. If we're going to insert A, this is the rear end, so it inserts here and it dequeue here. So when we insert or NQA, it goes here. This is index 0. At this point, the front is equal to 0 and the rear is equal to 1. When we insert B, at index 1, we have B, and rear becomes 2, right? When we insert C, at index 2, we have C, and this time, the rear value is equal to 3 because every time we NQ, we increment the rear value. And then next, if we dequeue, we increment the front. So front now would be from 0, it now becomes 1. So that is considered as deleted. The front is letter B now, and the rear element is C. So think of the rear as pointing to the next vacant space after the rear element. Okay, so this has index 3. And then when you dequeue, this is removed, front is equal to 1, which points to B. And when you NQ, letter D, D is here, and the rear value would now be 4, right? From 3, it becomes 4. So this time, front is 1, pointing at B, and rear becomes 4, okay, pointing at the next position with index 4. So when you inquire for the size of the queue or the number of elements of the queue, this would give us 4, the rear value, minus the front, which is 1, that gives us 3. We have 3 elements in the queue, and these 3 elements are first, letter B, second, letter C, and the third, letter D. As you notice, the first element we inserted or we NQ is A. Take note that the first to get inside is the first to get out, right? So when A being the first to get inside, we have A here or we have A here. When you delete from the queue or when you dequeue from the queue, it is the first element that gets inside, which is the first to get out. So we call queue structure as a first in, first out structure. First to get inside is letter A, and first to get out is also letter A. Okay? Unlike stack, that the first to get inside is A, for example, next is B, and next is C. The first to get inside is A, but it is the last to get out. So for stack, it is a last in, first out structure. The last to get inside, like this one, letter C. Okay, so this is the top end of the stack. The last to get inside, which is letter C, is the first to get out when you pop from the stack. But for Q, so this is our Q. This is the rear end, the front end. The first to get inside is A, is the first to get out. So again, Q is a first in, first out structure. And in the real world, we find several examples. First is line of vehicles at a traffic light intersection. This is a common example when you're on the road. So this is the traffic light intersection. We have here traffic lights. When it strikes red, the first vehicle will stop here. The next vehicle will stop here. The next vehicle will stop here. And this is the next vehicle. Another vehicle. Okay, so this is 1, 2, 3, 4, 5 vehicles in this queue. So this part here is the front of the queue, and this part here is the rear of the queue. It adds more vehicle on the queue when there are more vehicles arriving. So when it is red or stop, this is the first vehicle in the queue. The first vehicle in the queue, when this gives you a go signal, a green color, is the first to get out. So this is an example of a queue. Another is line of customers at a grocery store counter. So say this is the cashier. You have here queue of customer. We have here C1, C2, C3, C4, C5. The first customer to get in this queue, okay, so this is the front of the queue, and this is the rear of the queue. The first customer to get in the queue is the first to get out. The last customer to line up in the queue is the last to get out. Now, the same is true for line of clients at a bank teller window.